And welcome back. As we continue our programming journey, we're today going to take a look at something known as pseudocode and how we can use it to help develop our programs and algorithms. So when we actually start looking at developing our algorithm, dealing with the rules and the syntax of a programming language is actually not the hardest part of problem solving when it comes to developing code. The hardest part is often to determine the underlying method or solution. This method of solution is known as developing an algorithm. An algorithm, of course, is simply just a fancy way of saying a precise set of instructions that will lead us to a solution. And often that's a desired solution. We want to have a certain outcome that we're looking for. Now, when we start mixing coding and natural language, such as the language that we would write and speak in, we can generate what's known as pseudocode. So, what is pseudocode and how can we actually use this? Well, it's very common to use pseudocode or mixing of the code and human language to figure out the logic of what we want our code to do. This allows us to work out the fine details later. So for example, if I had a while loop and I want to, let's say, compare two integers, and then I'm going to have it output some value. All right, this of course would just be a quick example. You can see it doesn't have everything I need in there, but it's just a quick example, and I can look at this and I can figure out very easily translating this. Well, if I'm comparing two ints, that means I'm probably having two variables that I'm going to compare, probably with a Boolean expression, and outputting some value means I'm probably going to use a print line statement. So let's look at this with an example and kind of work through how we would use pseudocode. So let's say we want to solve how to read a number in from the keyboard and add it to a sum. We also want the program to exit after doing this 3 times. So let's problem solve. We know we need to capture a keyboard input. We know we'll be needing to add that input to a stored value. We know we want the program to be able to do this 3 times before stopping. We can also infer that we're going to needing to use a loop because you notice it's saying we're repeating a task and we're going to do it a set number of iterations. So let's actually start crafting the pseudocode based upon the knowledge that we have. Well, what we know? Well, we know we need to get keyboard input. We know we're going to be needing to add that input to a stored value. And we know we want the program to be able to do this 3 times before stopping. And we can infer that we're going to be needing to use a loop. Therefore, we can translate this into actually what we want to have for pseudocode. Well, we're likely going to need a scanner object called keyboard or KB, whatever we refer it to, that's going to capture that input using keyboard.nextInt. We're also going to need to have a variable to store that input, and we can call it, for example, like sum or some other equivalent value. And we're going to need another variable to keep track of the number of loops that it's going to be iterating through. So remember, we're going for 3 times, so having a variable such as count is a great way to keep track of that. And as I mentioned, we will need a loop, and a while loop will work perfectly fine for this example. We could, of course, use a for loop as well, but let's go ahead and approach this through the lens of a while loop. So let's actually look at some pseudocode now. So if we write out the pseudocode, we're going to get count equals 0, count equals num, because we have 2 variables we're initializing. We're going to input using the scanner class a variable called num. I have a while loop that says count is less than 3. So that means that there's my 3 iterations I'm looking for. Sum is equal to sum plus num, count plus plus. Input again using scanner class and stored in num. And there's the end of the loop. You'll notice in here, it is a mixture of both code and of written language. And so this is, again, not full code, it's pseudocode, pseudo meaning, false. So we, of course, are using language here to store out some of these other things that we know how we're going to code it, because we don't need to put everything here in our program. Now, obviously, you could use even more pseudocode than this, or you could use less pseudocode than this. This is a very simplistic example. But you can see that with this code, one of the things you'll note is that we didn't list out every single line, but we get kind of the basic idea across of what we're trying to do in this set of instructions. We can then take whatever we have written here in pseudocode and very easily translate that over to code. So here we are in Eclipse with that pseudocode copy and pasted into a program. And let's just go ahead and translate this from pseudocode into an actual program. Well, the first thing I'm going to do is going to start at the top and kind of work my way down. So I have count equals 0, sum equals 0. Well, I need to give these a type here. So this is pretty easy. I can just go ahead and make these integers. That'll clean that up. Then I have this line of code that says input using the scanner class a variable called num. So let's go ahead and create a scanner object. So scanner keyboard equals new scanner system.in. And then we're going to go ahead and have a integer called num, and we're going to equal that to kb.nextInt. All right, now we go to our loop while count is less than 3. we're going to have sum be equal to sum plus num. And then we're going to iterate that. And the input again uses the scanner class and stored in num. So we're pretty much just going to take this line of code that we have right here and replace this pseudocode. And so num equals kb.x allows us to get another line of input. And this would technically satisfy our program. Now, we could make our program a lot cleaner, for example, because right now we have no prompt. If we were to run our program, right now there's nothing to prompt it. So you'll notice, even though I didn't have it in pseudocode, it's still good for me to add additional things in here. So like, please enter an integer to be added. And then I, of course, can add this prompt down here after this iteration, and it could please enter another integer to be added. And that's a very quick way to help increase things in program. Notice I didn't need to put that in there for the pseudocode because it's not something that's going to necessarily solve the program's functionality. It's something that helps the user who's going to actually run the program, but it doesn't actually have any control over what that program is doing. So let's just go ahead and run our code, make sure it works. So please enter an integer to be added. So I'm just going to do 1, another, 2, and then 3. And it's saying it wants one more, so let's do 4. And notice now it's fallen out. Notice though, at no point we return, for example, the sum of those numbers. All right, so one thing to notice is that it does go for 4 because we are iterating inside this loop. So this could be a way for us now to look at this pseudocode and say, like, did this pseudocode correctly do what we want to do? And so I could very easily come in here in a system.out.println line to see if I have the correct number. And so if I rerun that with the same values, 1, 2, 3, and 4, you see we get 6. So it's adding those first 3 numbers, but we are getting one additional line of input. So there are ways that we could then revisit our algorithm to try and solve this to see if it's working better. For example, maybe we want to move this input to be solely inside of that loop, because that would, of course, solve this problem, because you can see we're getting one too many inputs. Another thing we could do is we could, of course, keep this and we could add a conditional statement that checks to see if we've done 3 iterations through that loop. And so if the count is already at 2, maybe we want to have it exit out, which is a break statement. But of course, that kind of defeats the purpose of having this loop here because we have a count is less than 3. So a better way of solving this would, of course, being able to move this inside of our loop, these 2 statements here, eliminating this piece here, because then, of course, we are not getting that one extra loop. And this, of course, ties back to what we talked about previously, which is using things like debugging and those techniques to see what are we having too many loops, are we having not enough loops. But again, this is all branching from our pseudocode because we use our pseudocode to kind of help us develop the techniques and underlying algorithms that we need to solve this problem.